Hello everyone. So my name is Jan Stuecke. I'm the product marketing manager at Apheris. No worries, I left the marketing in Berlin. Joining me today is our senior product manager, Chris. And we would like to talk a little bit about user-friendly federated data networks for life sciences. So I will give you a quick introduction to Apheris. And also introduce you to one of the key concepts that we follow at Apheris to make these data networks and data collaborations happen. Show you 3 examples that we currently have for data networks and how we power them. And Chris will then explain a little bit more about the architecture and how we make this whole thing flower-friendly. On the upper left graph, I think this is one of the most amazing graphs that I've seen in a couple of years. This is the growth of the amount of papers that have been published on arXiv about federated learning, and it shows the growth of a lot of the growth that we see there. And I think thanks to all the work that Flower and the Flower community is doing, which is a huge contribution to this graph. We are specializing on life science and healthcare, and what you can see in the lower graph is how many papers have been published on PubMed on federated learning. So also there's a huge growth in federated learning usage for those use cases. As you can imagine, life sciences and healthcare is highly regulated or highly sensitive data. So for our customers, pure federation would not work, so we needed to develop something in addition to that to make these collaborations happen. Our core product is called the Compute Gateway, which is installed at the data custodian side, so in their environment, so data stays home and computation just visits, so the classical federated learning approach. One of the key concepts we follow is something we call computational governance. This allows the data custodian to control, supervise, and monitor all the computations that want to run on their data in their environment. And it basically consists out of 2 pieces. So for the data custodian, they want to have control, and they get this with so-called asset policies. In these asset policies, they can control on a granular level which user can access the data with what model, what permissions this model has, and if they want to have an additional layer of privacy, they can also enforce the usage of differential privacy or homomorphic encryption. The counterpart is something we call compute specs. These are, as the name says, compute specifications where data scientists can see the asset policies and then match the configuration of the computation to fulfill the requirements set forth by the asset policy. And if this both fits together, we have a computational handshake, and a computation can be executed in a compliant and privacy-preserving way. This is all great in theory, but the question is, what real-world cases do we power with this? I think one of the most important projects we have is the AI Structural Biology Consortia, where multiple pharma companies provide their proprietary data to train a state-of-the-art model. And since today I'm allowed to talk a little bit openly or more openly about it, we will use OpenFold 3 in this project. That is powered by AbbVie, Boehringer Ingelheim, Johnson & Johnson, and Sanofi, and now also Takeda. And we want to train a model for protein structure prediction and also binding affinity prediction. And we just announced this project today. So very happy to share this with you today. A second project is a federated hospital network, which we build up in collaboration with Roche. It is a network that spans across countries with different jurisdictions that we have to make computations compliant for. So also highly regulated data, as you can imagine, patient data is highly sensitive. And we also needed to allow different models and multimodal data to be processed. In this project, it ranges from stats all the way to deep learning. And fresh out of the press, we have the ADMET Consortia, which we launched last year, which is also a collaborative effort to train models for ADMET prediction. So if you're not familiar with life sciences and drug discovery, ADMET predictions are basically predicting the properties of a compound in the human body. And this is a use case that is needed across the life science industry because every compound needs to be tested for these properties to move further along in the drug discovery process. And of course, this is also core IP of all these pharma companies and all the collaborators in these consortia. So we also need to take care of preserving the privacy and the confidentiality of this data. All right, so so far so good. My colleague Chris will now take over and share a bit more how we make this flower friendly.
Yeah, just kind of continuing from what Jan was talking about with these consortia and some of the partners that we have, more on the technology and architecture side, we have a lot of challenges, especially in getting these bigger pharmas to work together in a situation where they're willing to share their proprietary data, essentially. And so we kind of tackled that with a couple main pillars. Privacy is the obvious one. This comes up immediately with federated learning, but especially when you're talking about collaborating with competitors and making sure that they're not going to be losing their IP. And so patient privacy is the kind of given. We have to solve that. This can be, lots of different approaches exist, and that's ongoing. But then even things like data providers. So if there's hospital sites that are involved in this network, at any point during training or inference time, there shouldn't be a way to understand basically where the data came from. I shouldn't be able to isolate the specific piece of the data that was shared came from a specific hospital or something like this. And then the model IP privacy is always an ongoing concern, especially as these collaborations get more interesting than the person providing this model wants some assurances on that front. And I think this is already a big known problem with some of the secure compute talks from Intel and NVIDIA, and these are something that we're always working with these partners on with as well. So, but the biggest one and the regular challenge that we always see for us is this data IP. Now, the sharing of data from one pharma to, never sharing from one pharma to the other, but instead existing in these collaborations and making sure that, your direct competitor isn't getting your really valuable IP. Past those concerns is just the deployment, dealing with these really complex environments at hospital sites, at big pharma, at research institutes, and kind of everything in between. You have to have something that can be deployed there that mats their really high security requirements, and in some cases, really getting down to, historically sites that just don't even allow any form of internet access, and still kind of working with them to be able to participate in federated learning, which is always kind of an interesting challenge, and we've been able to work with them on that. And in this case as well with the limited IT resources. This is a lot of times hospital sites that aren't equipped at the moment for machine learning or federation or anything like this, so we have to have a team or a product that can work with them on that. And then in the end, of course, still being flexible enough to fit unknown workloads that are coming. And so this was our kind of main goal. And all of this, especially now getting into more of the flower specific part, is doing that without sacrificing usability. Still giving a good experience to the model developer, the ML engineer, data scientist, whoever's using it, and the actual custodian at these sites, and making sure that everybody can actually make use of the system. So the sort of challenge with all of that is that the expectation we get when we're going out and doing this is that this is what people expect the interaction and the architecture to look like, and this is as simple as they want it. And we hope, of course, that we deliver that for the data custodian. They just have an agent that's running, and this is what we call our compute gateway. And on the data scientist side, realistically, they just don't want anything about their workflow to change. And so that's our target, is of course always to get there. I just wanted to show for us, this is kind of our reality, especially on the infrastructure and orchestration side. It gets a little bit more complex. This is meant to more mimic a bit on the some of the components that we have and we're maintaining to deal with this user interaction side. On the right is this governance portal and CLI components we have. For the governance portal, this is how the data custodian's managing data sets that they want to add, how they're setting up the asset policies to run these computations, and their entire user flow exists through what we call the governance portal, just a UI for them to manage this. And the CLI is on the data scientist, ML engineer side. We have a privacy preserving statistics package that allows them to run federated analytics across multiple sites, as well as a CLI for managing their computations and their various jobs or model runs or even model development pipeline. And actually, I guess one more notable thing here is the call out of in vFlare is the federation engine we're using. And we've been with them for a while. They've been a really good partner with us. And we worked with them a lot on bringing up the Flower integration as well and making sure that we're going to be compatible and able to run these Flower apps so that we can support whatever workloads people want to run. Using Kubernetes, cloud agnostic, as I mentioned, we've got on-prem situations as well, and generally we've gotten positive feedback on the configuration and doing things like Helm charts to make all of this a bit more manageable. And so, yes, as of Apheris 3.6, you can officially use Flower-friendly federated applications in Apheris secure and govern application registry. So that means that you can do your full Flower or your full model development and bring that into Apheris. We have a pipeline that's managed for allowing you to push to GitHub. There's automated build action so that you can go from your model source all the way to the Apheris registry. And importantly, the data custodian gets to see this full record of everything that was done for development all the way up. This is optional. In some cases, of course, the model developer doesn't want any of this to be shared, and that's a bit up to the situation. But so Flower fits really nicely in there for allowing the developer to develop the way they want and still come into these really highly sensitive areas. And this is it kind of existing in our registry. This is our registry with a lot of existing models like Hugging Face or really anything that you want, XGBoost. We have a lot of existing models, but we've been really focused on letting you bring your own. So, and that's it. I think I got really close on time. So.
Time for a question? In the room? Yeah, right in the back. I'm going to run the mic to you.
Thank you. Hi, my question will be about the way, if you are doing already, how do you measure the value of federated learning in the context of the pharmaceutical companies? Is it, for example, do you see it should be measured that you bring the molecule faster to the market, or like how do you, because the consortium can be a great way, but then to keep these companies using federated learning and showcasing the value, I wonder like what kind of hypothesis, if it's possible to share, you run internally to measure the value of federated learning.
Yeah, exactly. So with specifically with some of the newer initiatives that we're working on, the approach we take is to that point, like how do you know after the end of these rather expensive training runs that it was worth your time? And so throughout it, we start with having each participant running their individual workloads, so running the training on their individual data sets. And as like, especially with the ADMIT consortium that we're working on, you run this and each pharma or each participant comes away with understanding how well their model is performing on just their data. And then throughout the process, they begin to understand if it got better or worse as we added in other participant data, and especially for the sake of like just making sure data integrity is there. You know, if pharma B said they were going to contribute their data and they kind of contribute maybe not so valuable data because they just want a free ride or for lack of a better term on it, we have to be able to keep track of that. And that's a lot of times where we come in, is making sure that everyone's playing by the rules that we set out and making sure that that's represented in the product as well. So I think if that was answering your question there, but that's our approach is kind of individually and then adding in participants and then evaluating the performance along the way.
Thank you. Next speakers.